Okay, so this is our final video where we're going to basically put all our lessons together. We're going to assume that we have 5 points A, B, C, D, E that define a conic. That is virtual because, in fact, I don't even need to see it, but I'm asking Geogebra to draw it. I don't use its shape in any way. I just use information coming from the 5 points to, number one, locate the center of the conic using, I think, information that we saw in video 3. And then secondly, to locate the two axes, perpendicular axes of the conic using the algorithm in video 4. And we're going to need the third component, which I just went through, which is how do you actually draw a tangent through a given a point that is known to be on the 5-point conic. So, you know, really the straight edge and compass view of this problem is this at this point. We don't know where the conic is. We have never drawn it. We just have the 5 points. We know where its center is, and we know the two axes. Okay. All right. Let's bring the conic back in so that we have some visual reference. Now, the last component that I said we needed was the tangent. So I'm going to ask Geogebra to basically draw this for me. But we know we have a pretty robust method to draw it, based also on Pascal's theorem, to draw the tangent through any given point. So here's a tangent through A. Let's make this tangent be perhaps dotted. Let's make it be dotted. How about that? Can I do that? I need to select that and say, okay, I want it to be dotted. Okay, so here's a tangent through A. So what are the steps? So what is my goal right now? My goal is to locate the vertices of this invisible conic. Where are the vertices of this conic? Once I locate the two vertices along the major axis and the two co-vertices, I can draw very easily the foci. And we're going to have finished our series of explorations here, of synthetic constructions of objects related to a 5-point conic. So the first thing you do is you draw a tangent through point A, could be through point B, doesn't matter, through one of the points. And now you're going to intersect this tangent with the two axes that you computed previously. Okay, there it is. Now I'm going to do a perpendicular projection of point A onto the axes. Notice that I'm only using information that I was given before. So here are my two perpendicular projections, and I'm going to mark them off. So here's 1 foot of perpendicular, and here's a 2nd foot of perpendicular. Now what I need to do is I need to draw a circle whose diameter is these 2 points here on this axis. Let's do that. In Geogebra, I have to first locate the midpoint of this segment. Then I can draw a circle. And what I want is a circle that has these 2 points as a diameter. I'm going to do the same thing up there. Let's mark the midpoint of that and that. And let's draw a circle whose diameter is that thing there. Now I'm going to do a crucial step, which is to draw a tangent, 1 or 2 tangents from point O to this circle. So Geogebra has that, but there's again a compass and ruler way of doing this. So let's assume that we know that, and maybe I'm going to leave a link in the description to how this is done. And I'm going to elect one of the two points of tangency. For example, the bottom one here, which is more accessible, and I'm just going to mark it off right there. Okay, and I'm going to do the same with the top circle. So I'm going to go from point O, and I'm going to construct the tangents from point O to this top circle here, and I'm just going to need to choose one of the two guys over here, for example, and I can even like hide the other one. Let's hide this one, and let's hide that other tangent. Okay, very good. So again, I have this one tangent to this circle, and I have another tangent to this bottom circle here. Now here's the magic. Let's now place our compass, our virtual Geogebra compass, on point O, and let's open up a circle that passes through this tangency point. And look at what happens when I do this. The intersection of this, let's make this guy be red perhaps, this red construction circle that passes through that tangency point. Let's let Geogebra put a name to this one, and let's let Geogebra put a name to this one as well. So this red circle over here, centered on O, that passes through L, intersects the x-axis precisely at one of the major vertices of the ellipse. So I can ask Geogebra to say, okay, tell me what the intersection of this red circle is with with this line. And by the way, this is a valid intersection in, let's say, synthetic geometry parlance. I'm asking somebody with a ruler and a compass to compute the intersection of a circle with a line, and there are two intersections, and they happen precisely at the vertices. So let's go ahead and mark off these vertices as green objects, because I've just managed to locate them. Here's one. Can I do this? Oh, hang on. I have to say, here's one object, and here's another object, and let's color them as being green, indicating that I've successfully, I think I have. It's not letting me, is it not letting me do this? It is. I think I know what it is. The top one is probably something else. So I'm just going to take the bottom one and color it green. Is that what's happening? Show object. There's probably a bunch of intersections here. It got stacked up. Here's another one. Let's see if this is the one. Okay, so I finally got green there. So I'm just indicating that I have been able to, using straight edge and a compass, I have been able to locate these two vertices. How about the co-vertices of the ellipse? Over here and over there. What do? I do the exact same thing. I'm going to open up my compass, starting from O and passing through M, that tangency point over there. Now notice how this construction circle here intersects the major axis which we have precisely at the co-vertices. Right there. So again, without cheating, I can say intersect this line with this circle, and I get these two, how about red points? This one and this one. I'm going to mark them as being red. There you go. So now I guess I could mark them as being green as well, because they're part of the green ellipse. Let's make them be green. So I have this guy, vertex 1. I have this other one, vertex 2. I have the co-vertex and the co-vertex. Now for the very last step, I want to finally identify the foci of this ellipse. How do I do this? I simply open up a circle centered at O with radius equal to, if I'm not mistaken, the semi-major axis. And I simply, actually, in Geogebra, what I need to do is use a compass tool. So I'm going to actually use the compass tool, open up a circle with this radius, and I'm going to move this circle up to the co-vertex. So I'm going to, you see, the circle was originally here. Its radius, looks like I didn't do this right. Hang on, let me redo this. I need to get the semi-major axis on this compass. So let's go to the other side. I'm going to go to this side over here. Okay, so I have now a circle whose radius is the semi-major axis. And I'm just going to lift the circle with the compass tool on Geogebra to the co-vertex, right there. Let's draw this circle as a blue circle. And I'm going to make it be dashed, like so. And it turns out, and this can be easily shown, that the intersection, again, of this circle with the major axis is the location of the foci. So I can just ask Geogebra, without cheating, to compute for me the intersection of this circle with the major axis. And it has lit up a couple of points. Now let's go ahead and clear off some of these construction lines that we drew before, so we can better see what's going on. Perhaps if I make my ellipse be slightly different, I'm going to get more distance there. This is what I'm trying to do. Okay, there you go. So it's the same construction, I just moved the point a little bit to the left so that the foci detach a little bit from my construction objects. Okay, so now I have these 2 points, which are the intersection of this blue circle with the x-axis, and I can check through Geogebra if these are indeed the focus of this ellipse. So I'm going to ask Geogebra to draw the foci of this conic, which I believe has a name. Let me just find it. It's called C. There you go. And I'm going to ask Geogebra to actually show their labels. Show me their labels. Let's see here. Show label 1. So he's calling the first focus Z, and it's actually falling exactly there. And the second one, which Geogebra is calling Z2, is also falling there. So this is just a confirmation that this purely synthetic construction, okay, departing from nothing else than 5 points in the plane, okay, and knowing nothing about the elliptic curve itself that goes through them, or the ellipse. Let's not use elliptic curve because this has a different meaning in mathematics. But knowing nothing about the actual curve that the conic that goes through these 5 points, this quadratic polynomial in xy that goes to these 5 points, we never computed that. Using just a ruler and a compass, we're able to do 4 things. We located the center O. We located the 2 major and minor axes of this ellipse. Then, in this last construction, using a tangent, we located the vertices along the focal axis and the co-vertices along the perpendicular axis. When we did that, it was a pretty simple step to actually go from this construction circle here and lift it up to this co-vertex here and produce this blue circle, dash blue, and its intersection gave us the 2 vertices. So there you have it. All the sort of principal or most important objects associated with an ellipse located using a ruler and a compass. Thank you very much for following us along, and happy 2022, and I'll see you next year. Bye-bye.